In this video, you're going to learn about the real number system. In the world of math, there is more than one type of number, right? But the ones that you know about at this point are all real numbers, right? There is such a thing called the imaginary number system that you will learn about in higher levels of math. So for the real number system, it is broken down into subsets, right? But the real number system, first and foremost, contains of two main categories, and that is your rational numbers and your irrational numbers. So those are the two main categories. You can be one or the other, but you cannot be both at the same time, right? Under the rational number side, you'll see that there are some smaller boxes, and those are called subsets as well. Irrational numbers do not have any subsets. So under the rational side, a number can be further classified as other types. The next category under rational is going to be your integers. And then smaller than that would be your whole numbers. And then the smallest subset of the real number system are what are known as your natural numbers. Right? And it doesn't always have to be using squares. Some diagrams use circles, some use ovals. It's the same structure as what matters. Some students have come up with an acronym to help remember the rational side. And if you start at the natural category and work your way out, they say never walk in rain, and that helps them remember the order in which they go. So if you need a mnemonic device or something along the lines of that to help you remember these things, then feel free to create your own or to use the one that's already provided. Now, the next thing that we're going to do is actually define these words, because knowing where to place a number is all based on definition. Once you know the definition, you can correctly place it, and it usually works in your favor. So the word real numbers is just like I had mentioned before. It is all numbers that are rational or irrational. So every number you know of is real right now. The next category is going to be your irrational numbers. Okay, and the way to remember irrational numbers, if someone is irrational, we kind of say they act crazy, right? So your irrational numbers are what we call your crazy numbers. And there's a reason that we call them crazy. These are your numbers that do not end, so they keep on going forever, or have a repeating pattern. So you'll notice that they are decimals, or numbers that can be written as decimals, right? And that they might have a pattern, but it is not a repeating pattern. If you can't put the repeating bar above it and the number never stops, then technically it's considered irrational. Okay, so we'll talk about some of those as well. Rational numbers, right? The best way to remember this one is using the word ratio right in the front, and a ratio can be written as a fraction. So when you're looking at your definition for rational numbers, and the reason there are so many of these, is that rational numbers are any number that can be written as a fraction. So there are lots of types of decimals and square roots and whole numbers and anything like that that actually can be turned into a fraction. If it's already a fraction, you don't even have to think twice about it. It's automatically rational. Right? So when we start placing numbers in the diagram above, we'll talk about how to know which one goes where. For integers, you've been using these for quite a while now, but integers are going to be all of your positive and negative numbers on a number line. And that on a number line part is pretty important, because on a normal number line, you don't have decimals or fractions, right? So when you say that part on a number line, you're actually telling yourself that it cannot be a decimal or fraction. So make sure you include in your definition part, no decimals or fractions. Technically, all of your decimals and fractions stop at the rational category unless they can be simplified. All right, so the next category or subset is your whole numbers. And the trick to remembering whole numbers is that O right in the middle of the word, because it represents a zero, right? And that's exactly what whole numbers are. They are all numbers 0 and up. And once again, no decimals or fractions. And then the last and smallest category are your natural numbers, also known as your counting numbers. When you first learned to count, right, you started counting 1, 2, 3, 4, 5. All right, that's why they are known as your counting numbers. And they are your natural numbers because we naturally start with them. So these are all numbers 1 and up. And again, no decimals or fractions. And if you notice these last two subsets, there is only one number difference between the two. All natural numbers are whole numbers. There's one whole number that is never going to be natural, and that's the number 0. So that is the only difference between those last two subsets. Otherwise, they're exactly the same. All right, so now what we want to do is take some numbers and place them in the diagram. When you're placing numbers in a diagram, you want to place them in the smallest subset that they go in. You don't want to write them in every single category they belong to. Now, on a quiz or a test, if we ask you to list or state all of the categories that a number belongs to, you do have to write them all out, right? But if you are placing them in a diagram, you always want to go for the smallest one that you say yes to, basically. All right, so the first number that we want to talk about is the number 36 over 6, right? So I'll write it above the top, but I'll erase it as we place it. Okay, so we have 36 over 6, and 36 over 6 is a fraction, okay, but it can divide. 36 divided by 6 can simplify to 6. So you're really asking yourself, where would I put the number 6? So your first immediate choice you have to decide is it rational or irrational? And because it started as a fraction, it's going to go on the rational side, because I know I can turn it into one. Once you're on the rational side, you have to then ask yourself the next series of questions. Will it be on a number line? Yes, it is. Is it above 0 for a whole number? Yes, it is. Do we naturally count to include 6? Yes, we do. So the last category we said yes to was natural numbers, which means in that box, you're not going to write a 6, you're going to write the original number. So 36 over 6 goes in the natural category. It doesn't mean that it's only natural. Once it's inside of one of the subsets, it belongs to all the other subsets that one is a part of. Okay, so the next number we want to take a look at is going to be the number square root of 2. And for this, you will need a calculator unless you already know enough about square roots. When we go to the calculator, this year in algebra, we are using Desmos.com for our graphing calculator. So when you go to Desmos.com, you want the graphing calculator, which basically means you just, after you type in the website and get there, you go to start graphing. And immediately what pops up is your graphing calculator. Now we don't need any aspect of the graphing calculator. So in the bottom left-hand corner, you'll see a keyboard with an up arrow. When you choose that, you get your actual numbers like a normal calculator. We wanted the square root of 2. Okay, so if you look over here on the left keypad next to pi, that's the square root button. So if I type in square root, you'll see on my screen that it opens up the square root sign. I choose the number 2. And then down in the bottom right corner, it gives me the decimal equivalent of it. I need to see that decimal to know where on the real number system I'm going to place this thing. So if I look at it, I see a long decimal. Okay, and I know that I can't make a fraction out of that, and that technically it doesn't end. Your calculator can only hold so many digits. Once it hits that digit maximum, it won't hold anymore. So just because it doesn't hold anymore doesn't mean the number stops. This number actually keeps going. So because it keeps going, and if you look at it, there's no repeating pattern to it, okay, then that means that this number is going to be classified as an irrational number. Once it's on the irrational side, that's all it can be. It cannot be anything else. There are no subsets to irrational. Okay, so we have that one placed. The next number we want to take a look at placing is the number 0. Okay, so if I think about the number 0, can I make 0 a fraction? Well, how do you make any number a fraction? The best way is to stick a 1 on the bottom. So I just made that into a fraction. So yes, 0 is rational, so it belongs on the left. Okay, is it on the number line? Of course it is. Is it a whole number? You bet, because that's what whole numbers start with. Is it a natural number? Absolutely not. So where the number stopped was in the whole number category. And again, that is the only place and the only difference you will see 0 is between whole and natural numbers. There is no other difference. Okay, so then the next number that we want to place is going to be negative square root of 64. Now, by now you should know your perfect squares pretty well, but if not, you can go back to that calculator and type it in. Type in the negative sign first and then the square root of 64. This is the same thing as negative 8. So we're really thinking about where does negative 8 go. Okay, well, it can be made into a fraction. Any number that is a number like that, you can stick a 1 on the bottom and you got your fraction. So it is rational. Negative 8 is on a number line. Negative 8 is not above 0, so it will not be a whole number. So we want to put negative square root of 64 here. Okay, the next number that we want to take a look at is the fraction 3/7. And I don't want you thinking too hard about this one, because if it's already written as a fraction, don't even touch the calculator. If it's written as a fraction, it automatically has to go rational. And on the rational side, fractions can't go any smaller. They cannot go in the integers, whole numbers, or natural number category. So rational numbers, 3/7, that's where it's going to stay, and that's all it's going to be. Okay, the next number we want to take a look at is negative 4.9 with a repeater bar. Okay, that repeater bar means that those 9s keep going. Yes, the number keeps going forever, but those 9s also keep going. Right? So when trying to decide if it's rational or irrational, it is not irrational just because it keeps going. This one has that repeating pattern, and that repeating pattern forces it to go under the rational side. So negative 4.9 is actually going to go over here with the repeater bar. So I usually tell students that the word repeat starts with an R, and so does the word rational. So as soon as you see a repeating bar or can put a repeating bar on a number, it immediately goes on this side. It is a decimal, so it's not going to be on the integer numbers number line or anywhere else in between. Okay. And then the only other one I want to have a discussion with you about or let you know more about is the decimal 3.101101110 ... Right, as soon as you see those ... that does mean that the number does not stop. It keeps going. So the next thing you want to look for is, does it have a repeating pattern, or does it just have a pattern? Well, if you're looking for a repeating pattern, that means that you can put the bar over it. If I'm looking at this number, there's absolutely no way I can write a number or decimal with a repeater bar. So that means that this number does have a pattern, but it's not repeating, which means it has to go on the irrational side. This is a tricky situation for some people to get their brains wrapped around. Oops. So you want to make sure that you understand the difference between repeating patterns and just patterns. Okay, so there's your real number system and all of its vocabulary and placements. We will do more in class with actual activities based around the system, but learn your words and learn their definitions, and it should work out for you.